Doesn't ring a bell, no?
I know your advisor was.
Okay, yeah. Yeah, the surest bet on any forestry like graduate, their advisor is Nielsen. I think at one point he had 18 people in his group, which is a lot.
Yeah.
That feels like a lot to me. I don't know. My smaller brain can only handle, my smooth brain is only good enough for like 5, 6 people in a group, and we got a lot of good stuff done, but my God, I can't even imagine 18. All right. Oh. It is.
My brother's advisor, he was in grad school. He had like the marine section, land section, and he had over 20 grad students. He's like, yeah, I sometimes don't talk to my advisor for like a month or so. I was like, oh, that sounds crazy.
There we go. All right. Cool. Okie doke. Go time. Okay, let's resume. We were talking about kind of the stages of the life cycle of the research process for any given phenomenon, and inevitably, careful explanatory work will unearth things that just push out past the limits of whatever, if you're doing deductive work, push out past the edges of what the general law or the general theory or covering law can explain competently. There's just, again, we call that hand waving when we get into stuff like starting to play apologist for a theory that is just kind of tapped out. Like it's explained everything it can, and there's just more to the story. In which case we sort of jump back to an exploratory mode of, okay, what about those parts of this complex phenomenon, or space, or area, or volume of time? Let's explore those and see if we can modify that covering law and expand it, or if we need to just, throw it on the pyre and torch it and build an entirely new covering law or theory. That doesn't happen so much anymore, but every once in a while you get into some of those things. So this is a cycle. It's here as a step model, but that's not fully strictly complete. So we got into kind of talking about the basics of exploratory work, and kind of left it at partway through the description stuff. Let's see here. There we go. And with descriptive research, we're talking, again, a lot of social research, like we left the discussion with on Tuesday. Because we can't do carefully controlled lab experiments on humans except for very specific and well safety mechanismed, hopefully, exceptions to that. Everybody's busy living their life, and so we have to do much more quasi-experimental stuff for anything that is descriptive or quasi-experimental. Early physical sciences research, right? So we're still mapping the oceans in higher detail. That is part exploratory work, like we're still finding new species all the time on deep sea dives and so forth. And we've got the larger sort of tectonic scale bathymetry set, so elevations but underwater bathymetry. But we don't have any sort of clear high resolution sense of 99.999% of the ocean floor, and that's not going to stay that way, right? Our mode of being as humans is to continuously push forward on greater levels of detail, greater levels of fidelity, additional variables, and so forth. So descriptive research, about as far as you can take the statistical, if you're doing quantitative descriptive research, about as far as you can take it conceptually speaking, on a research design and an analysis design level, is to correlation. You can say that A is related to B. Maybe it's directly related to B, so when A increases, B increases. Maybe they're inversely related, so that when A increases, B decreases. So down-regulating relationship instead of up-regulating, or covariance. And we can't test for causality. Causality is going to be one of the biggest things that is a hard sort on descriptive versus explanatory research. So the reason that we're sort of landing pretty hard on this correlation versus causation question is if you're trying to ask a causative question, does medicine X cause amelioration of symptom Y through mechanism Z? We have to have an experiment for that. We can't just give people a drug and look for, do people get better? Because if people are getting better, but we're not testing different ways, different mechanisms of getting better, or breaking the mechanisms we suspect that people get better or worse with or without a particular medicine, then we can only say that taking this drug is associated with people's improved survival rates or decreased symptoms, and so forth.
Question.
Yeah.
But if those research objects are getting better by their own and drug, drug don't have impact, but object is getting better anyway because of natural immune system. What then?
So fully controlled experiments with placebos, nocebos, positive, negative controls, all of that stuff. That whole dog and pony show is a lot. You know, randomized, complete block design, all that stuff. That helps to isolate that. And so in most developed countries, like federal or national government level medical research supervision or supervisory boards, they require drug companies, for example, to do experiments certain ways and with certain minimum sample sizes and to report data in specific ways so that you can objectively, so that anybody could look at those data and that research design and say, yeah, you are proving that this is not a placebo effect, and so on and so forth. So there's an inherent conflict of interest, of course, in having pharmaceutical companies, drug companies, pay for their own research and development costs, right? It's billions of dollars and typically a decade or more of time to bring a new drug to market. And most of them fail, like well over 90%. And the companies have to eat that cost. So in the United States, medicine is very expensive.
I smell lobbyism. Lobbying.
No, surely not.
So how to describe it in a socially acceptable way?
100%. No, there's lobbying, right? It's super corrupt. Anyway, so we want to, in thinking about your research questions, in your hypotheses, if you're doing a mechanistic study, am I asking a causative question? So this thing on watershed A caused this effect on watershed A, and therefore I will generalize that to watershed B, which is similar, and say this similar effect A prime or A star is going to cause the effect that is similar as well. But only testing inputs and outputs gives you correlation, not causation. Super, super important. So let's take some sort of obvious, absurd examples to underline this, and maybe think to see after maybe one or two examples if you can come up with an example of testing for correlation versus causation. So it has been observed that every person who has ever eaten pickles, ever, has died or will die eventually. 100% lethality rate. Very strong correlation, 100%. There are no exceptions. Unless, depending on your theology, you strongly believe that Jesus did not die and also ate pickles, but that's a very specific subset of probably Catholicism. I'm joking. So we can conclude, I mean, we have strong evidence, right? Our sample size is up in the couple of billion people who have lived and died and who potentially ate or did not eat pickles. So what's the problem with asserting that causative relationship?
Uh, technical question, for example, regarding pickles. So, how to, how is it? In this case, probably it should be put into consideration, is pickle cause of the death? Did person choke on the pickle? Did he got food poisoning from the pickle? And
Maybe.
so you want to say that 100% of people are choking on pickles? 100% of people are getting food poisoning from pickles?
Yeah, but that's not what this study said. It was simply observing the 100% lethality rate observed of people who have died.
May I ask evidence of diagnosis in this case?
Well, they're dead. I mean, there's...
Okay, but what is...
This study is not examining anything more than has eaten pickles, has or has not died.
But in this case, we don't have enough factors. So who could...
Says you. Okay.
Yes, I'm
That was a
saying
huge government-funded study. No, it wasn't. Obviously, so you would need to propose much more detailed research, and in exploring the finer question of pickle lethality, you could look at different pickled vegetables. You could look at different concentrations of dill and pickle vinegar. You could look at different eating dosages, time frames, exactly. You could look at cause of death and see, okay, this person ate pickles, but, you know, shot himself in the head, so I'm gonna guess that's an issue. It's hard to recover from that one. So we want to be very careful, especially, you know, trying on some of these statistical methods, especially early on, of making the slip up where, you know that a crosstab or a chi-square analysis where you're looking at frequency counts of levels of variable A, an input variable, and maybe counts of individuals who have each of the levels of variable B, and you sort of create a two-dimensional table out of that called a cross tabulation. And the statistical test to figure out if that is a randomly distributed table or if there's some sort of trend or forcing factor on the table is called a chi-square analysis for the parametric version of it. And you can get at some of these things. You can get at correlations with that. And if you feel like you really understand the mechanism underlying that correlation, the process, the procedure, the physical mechanism of it, it's so easy to say, well, A causes B if my chi-square test comes up significantly different from the null hypothesis. But that's not what it's telling you. It is telling you there is a correlation, and you need to do further tests that test causality and make sure that you're not violating the necessary and sufficient causality rules, essentially, and so forth. So a lot of descriptive research, we're just saying, yeah, this wildlife species, we're finding it around this particular habitat. That doesn't automatically mean anything. It just means that we're finding this species around this habitat, and maybe not another habitat that we also studied. We're not finding the same kinds of numbers. Question?
Yes, regarding correlation.
Mm-hmm.
What, how is it? If results are kind of expected already by common sense that this object A is correlated with object B, and it's like common sense that fire is hot, ice is cold. Common sense. But the common sense, you cannot put like that in a scientific approach. So how to deal with
Sure
that?
you can. Science is all about characterizing what you observe. That's the whole point of it. If it can't characterize accurately what you're looking at or sensing, then...
But the main thing is, different people has different, how to say, criteria of common sense. So what is kind of obvious to one person can be questionable by another person.
You bet. That's how we get anti-vaxxers.
Yeah. So the main question is, how to put common sense in scientific way?
You don't. You drop kick common sense out the window and you test everything. Remember, in God we trust, all others bring data. People can't argue with your data. So, you're talking about hot and cold. Those are common sense things. No, they aren't. They're data. Right? What is the temperature of the thing? Nobody can argue with you if you hold a thermometer to the thing and record the number on the thermometer, or zap it with an infrared thermometer or something like that. That's just not under dispute, right? So it might feel like common sense to say, well, ice is cold, but in a deep space vacuum context, ice can be hundreds of degrees warmer than ambient. Does that make sense?
Yeah.
Yeah. Okay. So close to absolute zero, ice could be relatively quite hot. So we just take away those relative descriptors. We take away common sense and we replace that with empirical observations and objective tests. This chi-square test, as an example, this ANOVA, this linear regression, all correlative analyses. They don't care about your hopes and dreams. It's just an equation, right? It's just going to spit out whatever summary number captures the relationship of the individual numbers that you've recorded as data. There's a hand over here. Yeah.
So, when it comes to presenting your results of like a descriptive research project, would it just be like my results are that we examine the correlation, here's the correlation? Or like, is it still too much to say that like eating pickles may cause death? Is that still like extrapolating too much? Like, so you don't talk about causation at all, you're still only talking about correlation.
That's a great question. And this is a very important question with today, where we have essentially a global now research community all contributing publications online and so forth. What you'll tend to see in publications that are not fully baked in terms of the analytical thought going into the discussion and the conclusion sections, which is where you talk about what the correlation might mean. If this research study that you're reading about or writing about is part of a larger program of research, say your master's degree was on, or in your undergrad program of study, you learned about a bunch of exploratory research that was done on desert tortoises 30 years ago. And your master's degree is on your research project about desert tortoises, describing some particular part of their habitat versus population versus climate shift dynamic. And you say, within the time frame that we looked, the 1.1 degree Fahrenheit increase in average annual surface Earth temperature for this desert tortoise habitat coincides with, is correlated with, a 0.2% decline in tortoise population. And we measured the physiology of a whole bunch of captive wild tortoise, and we noticed their serum concentration of this particular stress hormone increases non-linearly with increasing temperature. And the temperature change in the habitat overlaps with where the stress response of the tortoise goes into orbit. Okay. So you would say, you know, we studied these things. We haven't taken 500 desert tortoises, because we can't find 500 desert tortoises, and stuck them in cages and put heat lamps on them and manipulated experimentally the heat lamps for this set versus this set and so forth. We suspect that there may be a causative relationship based on the strength of the correlated relationship that we did find. You're not saying it's causative, you're saying it's possible. So what that discussion and really that section in the conclusion, subtitled Recommendations for Future Research, what that's really saying is somebody should really clone up 500 desert tortoises, so we're not, you know, using up our limited stock, and just blast them with heat guns, you know, just see what happens, right? Maybe they pop like popcorn, I don't know, but that's terrible. Don't talk about that. They're a protected species, come on. So you are hearing a lot of kind of mealy-mouthed language. It may be, it has the potential to be, we cannot reject the possibility that you tend to see that kind of a language where the person really wants to speculate and they want their name attached with the idea. Hopefully it becomes a theory when folks start researching it and doing mechanistic, causative studies on it. Want their name attached to that because they were the first one to propose the idea, right? So that's how this can happen. And sometimes the work is perfectly fine descriptively, right? So for the studies that Monsanto or whomever else, DeKalb or whatever, they want to put out to Natural Resource Conservation Service technicians who are working with farmers locally, it's totally enough for, as long as it's a reasonably well-designed field study, for them to say, hey, you know, if you use our seed stock, which we modified to be Roundup ready, and you hose down those plants with glyphosate, Roundup, chemicals, then this is the observed descriptive difference in productivity per acre, and here's the extra cost per acre. So you're paying a little bit more to spray those chemicals on and to pay for our fancy GMO seed, and you're producing twice as much. You're losing less to spoilage, to insects, to fungus, whatever, and so forth. That's a purely descriptive study. That study isn't asserting anything about how glyphosate works. It's not asserting anything about how corn grows. It's just saying, look, spray this on, and this is what we found across a whole bunch of fields, and this is how sure we are. Here's our margin of error. Here's our sample size. Here's our F statistic, our power, and so forth. So there's nothing wrong with a correlation study. There's a lot of work that goes into these, a lot of hard work that goes into field studies. But we don't want to make the mistake of, especially early on in a career, kind of jumping too far with this. Well, I've shown that, you know, glyphosate makes this corn grow more. That's not correct. Glyphosate causes less loss. Yeah.
So with working with humans and in an experience and looking at an experience of humans, would you get to a point of having any kind of causation, or is it mostly correlation?
It's a lot of correlation, and over years, and even in some cases decades, folks will do smaller studies that can look deeper into mechanisms and processes, but typically not in a deductive way, usually more in an inductive way, like semi-structured interviews, conversations with folks. So walk me through what you were thinking when you were just going through this experimental procedure, right? You are directly getting at the mechanism, or at least indirectly getting at the mechanism of how someone thought about something, how they experienced it, what they believed about it, what their attitudes about that decision or choice that you've posed experimentally might be, what they think their friends think about them thinking about it. So that's so-called conventional moral development or pre-conventional moral development as part of a decision-making process leading to behaviors, and sitting down with somebody afterwards and kind of debriefing in real detail. A lot of times you can say, look, this is what people are telling us, and we're correcting what folks are telling us based on things like there's like a positive perception bias typically when somebody is interviewing you and they've got a lab coat because they're a social science researcher and they must be serious because their name's embroidered on there. There's a real perceived pressure in people to try to say things in a way and to say content of things that I think will please the researcher or make the doctor happy.
It gets influenced by
Yes, absolutely. Absolutely it does.
It's just a gal in a t-shirt.
Correct. That's a real thing. So there are observed differences between male and female interviewers asking the same questions with the same vocal inflection and so forth. There are differences between, perceived race or ethnicity. Not necessarily actual race or ethnicity, but what the interviewee thinks the other person might be. It's called attribution bias. There's differences on how people will respond young versus old, or sort of one set of studies kind of boiled all of those things together and said, okay, what's the perceived alikeness of the other person? Not necessarily even just in an interview context, which is a very limited context, but just in, I'm encountering somebody on the sidewalk. Are they approximately the same physical size and stature as me? Are they the same outwardly expressed sex as me? Are they the same ethnic group that I self-identify into, or groups? Are they wearing clothes that are alike to mine or not? We're automatically all making these unconscious evaluations or preconscious evaluations, and that really does steer how we interact with people, which makes sense, right? You don't interact with an infant in the same way that you do with a 57-year-old colleague. You don't, and we generally as societies think that that's appropriate. And that makes sense in terms of just raw cognitive development. But we do have to factor stuff like that in
And how do you
on a study like that.
conduct an interview that removes those biases? Because to some extent, like, you have to have that conversation with a human, but those, especially in the experiences that I find myself in, there's the human-to-human biases as well as environmental. And so how would you go about conducting some sort of interview?
Yeah, so yeah, let's ask how do I prevent biases of just being the interviewer I am? I can't change that, and I certainly don't want to cause a very different kind of problem with, I don't want to assume how somebody else speaks or their body language, based on what I understand or maybe stereotypes I hold about their culture or subculture or whatever. For interviews specifically, you're trying to generally find wide ranges of people to help sort of smooth out that effect. Some people will be biased towards you, some people will be biased away from you, and so forth. So you're trying to sort of embrace the biggest, most diverse group of study subjects that you possibly can, and kind of average things out a little bit that way. There are also specific interview techniques that help to avoid at least avoid inflaming some of those, biases of we're going to use certain kinds of words and absolutely avoid other kinds of words. We're going to state over and over in the invite to do the interview, in the preamble to the interview, in the after action, the debrief of the interview, hey, this is how we're going to use these data. Hey, these are some things that we will never do with your data. We're never going to hand this interview transcript over to law enforcement. We will not do that. We'll talk about more of that stuff in the ethics section of the class.
Exactly. My question about ethics is the morals.
We'll get there. We're not there yet.
Short question.
Short question. All right.
Okay, so basically setting priorities.
Yeah.
Because social sciences cannot be conducted on animals, only on humans. And for example,
we conduct experiments on animals by the thousands right here at SIU.
Okay. Yeah, kind of. Anyway,
no, we totally do.
For example, a researcher has very important goal, like achieve peace on the world, global peace.
Yeah.
So he is conducting his questionnaire, his interview, but from some people's perspective, he is asking not very ethical questions. So how to set priorities? Peace of the world, or morals and the respect of ethics? How to set priorities? What is more important?
Yeah, we're absolutely going to talk about that in detail in the ethics section, which is kind of like after this one. So we're going right there.
Thank you.
Like, we're going to talk about how your society and mine has decided to poison all of us low key so that we have a lot less tooth disease. Okay, we're going right there. And there are a couple of different ways to answer those questions, and it's very important that we are aware of how folks decided those questions for us. Okay, so yeah, in trying to minimize a lot of those biases, we'll get more into that with methods later on, but the sense of it is we're going to use standardized techniques. We're going to try and make things as inclusive for people as possible. In the ethics section, we'll talk about harm prevention and reduction as well. We'll talk about how there is, for social research, where the researcher is just, irreconcilably different than the population or the group that they're studying. That's not any reason to slow down on the research. It is every reason to take time to legitimately earn acceptance and access to that otherwise closed community. So, for example, one of the guys on my PhD committee was doing some pretty not controversial, but
Questionable?
no, it was really ethical research aimed at exposing difficulties or unintended consequences of federal governments establishing national parks in the territory or normal habitat, cultural habitat of indigenous humans. So, folks who have been living in various places in Central America and in the Caribbean, across some of those islands, in the 80s and 90s, there was this huge wave of let's bring a whole bunch of Western tourism dollars to some of these developing economies by setting up ecotourism. And it's going to be these cloud forest, treetop villa, national parks and zip lines and stuff like that. And it's not going to harm the local environment. And rich people will show up, they'll dump a bunch of money, and then they'll leave. It'll be great. But in order to have those national parks where you can do some of those things, with the shiny Carnival cruise looking scuba trips and stuff like that, you have to take over that area. And if there's an inconvenient village, I'm being sarcastic about the inconvenient part, like those people have every right to exist and exist there. Like development experts, ecotourism experts with like the United Nations and the United States and other, developed countries and stuff like that would show up at these places in Costa Rica and say, hey, let's let's create a national park here. And these are my projections, which are generally correct-ish, about how many millions of dollars this is going to bring into this local just subsistence economy. It's going to be amazing. You can build hospitals with this. You can really raise people's standard of living, have a lot less infant mortality, stuff like that, all just from tourism dollars. We just put the park right here. Here's the access from the airport, right? This is a package deal. This will work. And it did. But it kicked a whole bunch of people off and made them illegal, basically. So people were getting thrown in jail for going into what is now a national park as of yesterday with a stroke of a pen somewhere else in some city, and getting arrested for things like gathering firewood for their cook fires to boil their water to make it safe to drink, right? And they weren't doing anything different from the week before, but the designation of that land had changed. And so this researcher, Mark Stern, wanted to look at that and just kind of catalog some of these harmful effects on real people that have been happening for the last couple of decades now. If you've ever been on a cruise, think about the sharp economic divides of where the cruise lets off 3, 4, 5,000 passengers over the course of an hour at some little tourist town, and then around the edge of the town is absolutely desperate poverty, like some of the cruise passengers have never even seen before in their lives. They couldn't even imagine it. And so sometimes the cruise companies, like Disney owns entire multiple islands of the Caribbean, excuse me. And so on and so forth. So there's always winners and losers. Mark Stern wanted to learn more about, what's going on with some people who have lost in this sort of economic development push through no fault of their own. So he would spend up to a year living in a village just to become a familiar face, just to greet people on the way to the market, meet people at the well, how a lot of people live. And after that year was elapsed, after people saw him and had come to trust him and accept him as just another person sweating it out in the tropical jungle, then he could start some interviews and ask, hey, it seems like some people are kind of frustrated about some things. I'd love to learn more about what life has been like for your family over the past 10 years, kind of before and after effect of whatever the economic change was, or the legal land designation change was. And he found some amazing stuff, just heartbreaking things. But not a lot of people were looking in that direction for data. And partially because, you might be spending a year of your life not even doing the research yet, not allowed to do the research yet until, for example, your research board says you have to be accepted by the village elders formally before you can ask one question about this. And if it takes you a year to get there, then it takes you a year.
Wait, what does it mean accepted formally? Did you become like tribesman? What is the description of?
Not so far as that.
Formally becoming part of village.
Essentially, the goal there was to make sure that the people got to decide with informed consent whether Mark was allowed to even ask those questions, if he was allowed to have standing in that community to begin speaking, right? In a lot of places, showing up as a white guy is not a good thing. It's like, I'm from America and I'm here to help, and people are running the other direction because,
Stereotypes.
yeah, something colonizer. And that's real. Like that's real people's real experiences, and a lot of them. So that's another part of it. And that's not appropriate for every research project, but for those where it's needed, and that's an ironclad thing. So the researcher typically has to go before a board of dispassionate folks in the institutional review board and say, here's my entire protocol, here are the people, here are the risks involved, all of them. And it's even the nitpicky small stuff that's probably not going to happen and mostly isn't even my fault. But the fact that I'm even there in the first place is changing the situation for these people. So they'll go through that with a fine-tooth comb, and in a non-expedited review for something like that, they'll spend weeks on it. if you're doing a federally funded research project that has any of those potential harmful side effects or whatever with your interviews, with protected populations of children or prisoners or, you know, developmentally delayed folks or neurodiverse people, that federal review, the expedited review for the non-controversial stuff takes 1 to 2.5 years, right? They are not messing around with that. So there's a lot of careful scrutiny and thought about what are the biases? What are you doing to sort of get after those? How are you protecting the people? Where even just deception is required, why do you need to lie to your participants about XYZ? A lot of psychology studies involve a little bit of deception where you're asking them about one thing, but you're watching something else, like asking a verbal question, watching body language. Yeah, exactly. But even to do that level of deception, you have to very clearly state all of it, you know, and justify why you have to use deception. That's a real thing. And in the ethics section, we'll get into some amazingly bad experiments, just trash fires. Okay, so long answer to that one. And we'll go deeper into that and ethics quite a bit. So all I have to say, correlation, whether through interviews or with the Great Basin Institute out west in Nevada or wherever it's at, we're not talking down about correlation type studies. This is important stuff. This is how a lot of work gets done. And this is the work that we have to have before we can even start to think about causation, explanatory, mechanistic studies. So here is a little bit more of that differentiator. All right, so descriptive research, we're generally talking in the univariate. What's the average of this? What's the range of these values of this attribute of the species or the phenomenon under study? And then bivariate or multivariate, so cross tabulation is at least 2-dimensional. It can be n-dimensional, 3 and higher dimensions, and so forth. And then most of you will have probably up to about linear trend modeling with your first or second graduate stats class. Explanatory research, we're going into much more detail, and we have to check some more boxes. We are, in explanatory research, always collecting the descriptors that have been previously defined and explored in descriptive research. And we are also building in things like we're testing for what input variables or what combination of variables or what sequence of variables in a longer, more complex process, what are necessary. You have to have them in there in that order, in that arrangement. Those are necessary causes. What if we are testing multiple parallel sufficient causes? So for example, if our mechanism is to explore why does the Southern Appalachian mountain chain have a bunch of open grassy areas just right along the spine of the ridge and everything else is forest around it. And it's super weird. And it's a very clear divide in terms of local ecosystem. That could be from a bunch of different things. It could be a fire regime thing. It could be fungal. It could be land management from Native Americans that is still visible centuries later. It could be any of those things. It could be combinations of those things. So let's try out some different, potentially parallel sufficient causes. And where those causes might interact, let's test out some contributory arrangements. So if A, then B, then C is a sequence of necessary causes. If we remove any of those three, A or B or C, we can't get through C from A. For a sufficient cause, we might have A or B or C all leading to D, each in their own way. We can test each of those mechanisms. See what breaks the arrow between A or B or C to D. And with a contributory cause, we have, okay, this factor doesn't drive the reaction, doesn't force the mechanism, doesn't cause the mechanism to happen. but it does influence it if it's present. It's a contributory cause. Okay. So in that case, you can imagine fairly complex systems like a human body or a desert tortoise physiology or climate change has some necessary causes and it has some contributory causes and so forth. And it's all pretty complex. So in that case, with explanatory research, we're doing things like structural equation modeling. So a very simple structural equation model might be that A or B or C, but really C is just a precursor or an antecedent to D, and the downstream effect that we are shooting for, the surgical outcome, the medical outcome, taking medicine, or the nutraceutical outcome, healing a person, that's all E. Different ways to get there. So structural equation modeling is, this is a set of experimental trials. We're trying different levels of A, seeing what happens with our downstream E. Different levels, intensities, timings of treatment B, seeing what happens when we get to E. And same thing with C through D to E. What structural equation modeling is doing is essentially putting together a detailed linear, usually or nonlinear trend for each one of these arrows and assigning it a strength. So this is 0.09. If that's an R squared statistic, you could say that 9% of the behavior of E is driven by, is caused by factor A across its different treatment levels and so forth. So if we give somebody aspirin, 10% of their headache goes away, 9% of their headache goes away. For B, maybe it's a 0.32. And that's pretty good for social research because humans are weird, complex, and illogical, and don't sort well into boxes. When you chop somebody into pieces and try to sort them into boxes, they die, right? So, and that's pretty good for social research. For an ecological process where you're dealing with millions or more data points, you're looking for something like 0.6 to 0.9 something. That would be considered a strong causative factor. Up to 90% of the behavior or the outcome represented by variable E depends on C, modified by D. But without this C, we only get 10% of any behavior, or something like that. Okay, so a structural equation model, these can get very complicated. It's like a flow model, and everything is flowing from input variables, independent factors, down to dependent or outcome factors. And you can test statistically if you're doing a statistical style quantitative nomothetic test, or experiment, excuse me, what the relative contributions of all of these things are. And so now we have a sense of sufficient cause for outcome or phenomenon E. We now have a couple of different ways that we can manipulate E. And when we mismanipulate one of those, when we interrupt the process of A to E using this intervention, we don't get any change in E. That's a causative establishment, right? We're saying that if I interrupt A, then E doesn't happen. And so A, I've proven that it causes, or I failed to reject the idea that A doesn't cause E. Statistically is how we say that. We reject the null hypothesis that A does not influence E, because I've shown at least 9% of the behavior of E numerically is a function of A. And here's the mathematical function that describes that 9% of behavior. That equation is the equation of that straight or bendy line, linear or nonlinear trend. Okay, so that's a conceptual level of statistics. There's a whole lot more computation, but that's a very basic, about 3-minute intro to how do I prove something? Well, we're not proving something. We are rejecting the idea that A is not leading to B, or E in this case. Okay. So what this requires of us, and we'll end on this one, is thinking about hypotheticals. If you wanted to explain campus awareness as a human social issue of sustainability issues, how would you measure that? How would you model that if you want to try and get after statistical causality? All right, so just a little informal assignment for us for Tuesday. How would you research to answer the research question of campus awareness of sustainability issues? What causes awareness or lack of awareness of sustainability issues around campus? Okay, very straightforward question on the surface. Lots of different ways we could answer it. With descriptives, with univariate, bivariate summary stats, and maybe we could start getting at some kind of causality tests. Maybe not. Think about it for Tuesday, okay? You can take a qualitative or quantitative, that is an inductive, ground up, or top down, deductive, covering law model to answer your question. Cool. All right. I know we raised more questions than we answered today, but we are steaming hard. We're on the Cleveland steamer toward talking about ethics and biases. All right? Hang in there. Cool. That's it for today. I'm around for questions. Informally now. See you Tuesday.
Okay, so may I ask you for consultation